Well, greetings, mathletes, and welcome back. Today's adventure is going to be a continuation of finding areas under curves. Last time we looked at constant functions, and so we had to understand how to find the area of a rectangle, and then we had to figure out, how to find the sides of that rectangle. Well, today we are going to be looking at the area under a linear function, and so those go off at an angle, right? And what ends up happening is you form trapezoids. So we have to understand how to find the area of a trapezoid. So let's go ahead and take a look at that. Now, um, let's see, make sure we got everything on here. Now, normally we see the area, when we're given a trapezoid. A trapezoid is something with exactly, well, not necessarily exactly, it has at least one pair of parallel sides. So in this case, these would be the parallel sides. Now, under normal circumstances, when you're dealing with things in a geometry sense, usually this is called base 1, this is called base 2, and then this is your height, right? That's how you end up computing it. And then the area ends up being the average of the two bases times the height. And it's not always written in that order. Sometimes it's written 1/2 the height times the sum of the bases. But really what you're doing is you're averaging the two bases and multiplying it by the height is what you're really doing. Now, we're not going to be looking at them in this orientation because the stuff we're going to be looking at, we're going to have some line and then an area underneath the line. And if you notice, this forms a trapezoid as well. I'm going to erase some of this other part of the line here. It's just up and down instead of left and right as far as which sides the parallel lines are. So the way we end up altering this formula, since it's turned on its side, these don't look like bases anymore. They look like heights now. And so just to make the what do you call it? The formula make a little more sense. If we're oriented this way, we'll call this height 1 and height 2, and then we'll call this the base, right? So these are now height 1, height 2 instead of base 1, base 2. So since we turned it on its side, base and height reverse. The area then is now well, actually, let me write it so it's in the same format as the other one. H1 plus H2 times the base, right? So this is the formula we're going to be using. We're not going to worry about this one for the moment. This isn't wrong. It's just not going to be useful to us right now. So this is not useful. Okay, it is correct. All right, so let me go ahead and get that off of there. So that's not going to be the one we're using. We're using this guy. All right, so actually let's take a look at an example. So if I have a trapezoid here, and I have some of the side lengths, let's see, let's say this side is 6 units, this side is 11 units, and this side is 8 units. Okay, so if I have these three measurements, then what I can do is plug them in, right? This is 6 is my base, height 1 is h, and 11 is height 2. So I need to use this formula, a equals 1/2 h1 plus h2 times the base, right? Just a word of advice when you're memorizing a formula, when you're learning a new formula, it really, really, really does shorten your study time if you just write the formula every time you use it. It just reinforces it and you have less time to spend memorizing. So it's a good idea to write this down. But now that we have everything labeled, all we have to do is plug these guys in. So H1 is 8, H2 is 11, the base is 6, right? So now we have all the pieces. We just need to add them all together and do our multiplication and all that stuff, and we win. So now this is 1/2 19, 1/2 of 19 times 6, right? And actually, since it's multiplication, I can multiply in any order I want. 1/2 times, so I'm just going to multiply the 1/2 and the 6 first instead. So now that's 3 times 19. And 3 times 19, well, let's see. 3 times 20 is 60, right? And that's 23s. So if I only have 19 of those threes, that means it has to be 3 less than that. So it's 57. So it's 57 square units is what we're looking at, right? But you notice what I did. And by the way, you're absolutely permitted to use a calculator. If you want to plug this into a calculator, plug it into a calculator. Make sure you use your parentheses though, because if you don't, you'll get the wrong answer, right? So, in fact, I can already see if you screw up your parentheses, you end up on this one, you end up getting 90 instead of 57. So, I would actually advise that uh, what do you call it? You try this one and make sure you can plug it into your calculator correctly and that you get 57 from it. So check that on your calculator real quick. If you don't get it, um, well, that is probably something you're probably missing parentheses. But if you can't figure out what you're missing, come and talk to me. Okay, so let's look at one more example here. So let's try that again. I was trying to do that. Okay, and I'll go ahead and delete. Okay, so this one will be for you to try, and that's a straight line. That diagonal one. This is a there we go. Close enough. Now you can tell. So this is now 6.1 times 4.7. I would advise a calculator with this one, and the base is 19.2. Okay, so what I want you to do is go ahead and pause it here. See if you can use the formula correctly, and then play it once you've finished working on it, and see if we match up. Okay, so go ahead and pause it here, and then yeah, and when you're done, go ahead and push play. Okay, so I'm going to assume you've already paused it, and we know our area is 1/2 height 1 plus height 2 times the base. Okay, so now we just need to identify these things. So this is height 1, so this is H1, this is H2, and this is B. And we just need to plug things in. So this is 1/2 times 6.1 plus 4.7 times, where'd the last, oh, 19.2 times 19.2. And so that's just something we need to put into the calculator. So let's start, well, I'm going to start in the middle, 6.1 plus 4.7. Okay, and that gives me 10.8. So now I have 1/2 times 10.8 times 19.2. And what I'm going to do is I'm going to multiply the two decimals, and then instead of multiplying by 1/2, I'm just going to divide the answer by 2. So 10.8 times 19.2 is, let's see, that's the 1/2, so that's 207.36. And if I cut that in half, I get 103.68 units squared, right? So you should have gotten that answer also. Hopefully you did. If not, go back through and double check things. Make sure you use the parentheses correctly. Make sure you were following the order of operations when you worked out all this business right here, right? You should actually be able to plug the entire thing into your calculator all at once. But if you did it piece at a time, you should be able to match up the numbers that I came up with as I was going here. All right. So that's our second example. Now, we need to start talking about the actual area under a curve. So let's go ahead and delete this, and we will take a look at that now. Okay, so now we've been talking about the area under a curve. I haven't really given you a curve yet. All I've done is given you trapezoids. So let's actually take a look at something here that we can play with. So let's, I'm not going to use actual numbers. I'm going to do this a little more formulaically first. So first off, you're going to be given a graph of some piecewise function, and you're going to be given a function, a linear function at that, a plus bx. We've seen that form before. This will have endpoints, but the area that you're going to find will actually be encased inside of this thing. And like you'll have endpoints over here, but the area you're going to end up looking for is going to be this smaller area here. And you'll be given some value of x, x1, x2, right? And those are your boundaries. So you end up having to deduce all the sides of the trapezoid. You can probably see the trapezoid here. It's actually kind of hiding right here, right? And so let's look at some of the things that we need to find. We need to find height 1 and height 2, and we need to find the base, right? Because that's what our formula says. A is equal to 1/2 height 1 plus height 2 times the base. Well, we don't know the base, right? All we know is we have these two numbers. So the base, and I'm not using b because I don't want to confuse it with the slope up here. I'm just writing the word base. In fact, let's write it in here so it's not confusing. The base is always going to be the second x value minus the first, right? That's the size of the base. Now, the height, if you want your heights, if you want to know how tall this is at this point, what you do is you take this x value and you plug it into the function. So the height here is f of x1, and the height on this side is f of x2, right? Now, this is all symbolic, so it's very possible that this looks a little crazy to you, but once we start looking at the actual numbers and seeing how things work, it won't be too bad. So make sure you have this down, because these are the things we're going to need for the next part of this. Let's see if I can do it without having to erase this, but we'll see. I may need the room. Okay, so this time I'm actually going to give you some values. Okay, so this runs from 1 up to 10, right? However, the area we're going to find runs from 5 to 9. So that's your x1 and x2. And we want that area in there, right? Okay, so we need to figure out what the heights are, and we need to figure out what the base is. Oh yeah, and I have one more thing to give you, and that's the equation of this function, which is f of x, oh, it's going to get in the way, is 2x, oh, excuse me, my bad handwriting. That's supposed to be a plus. 2 plus 0.7x. Let me write that neater. I'm just going to get this thing off of here. Two plus 0.7x. Okay, so that's the equation of this line if we extended it. Now, so to fill out our formula, and I'll go ahead and write it up here. A equals 1/2 h1 plus h2 times b, base. Okay, so we need the base first. Well, it doesn't have to be first, just whatever you want to find. So our base is x2 minus x1, which is 9 minus 5, which is 4 units. So now we have the base. The heights, I need f of x1. In this case, it's 5. And so we're just going to plug it into this function up here for x. So it's going in right there. This is going to be 2 plus 0.7 times 5. And I'm going to use the calculator for that. So that's 2 plus 0.7 times 5. That gives me 5.5. So that's H1. And then H2 is going to be f of 9, which is 2 plus 0.7 times 9. And that should be 8.3, but let's double check. So it's 2 plus 0.7 times 9 equals 8.3. Right? So that's H2. So now we have all the pieces. Right? We have H1, we have H2, and we have the base. So once we have those, and I'm just gonna get rid of this. We can just plug them into the formula. Okay, and we know the formula. A is equal to 1/2 times H1 plus H2 times the base. Now it's just a matter of plugging things in, right? So our base is 4. I know that. H1 is 5.5, so this is 1/2 times 5.5 plus 8.3 times 4. Okay, so this time I'm just going to plug it directly into the calculator, and I think let's do it this way. All right, let me go ahead and clear this off so you can see the whole business. Okay, so I have 1/2 times 5.5 plus 8. In fact, I'm going to do this instead. I'm going to do the 5.5 plus 8. I'm going to follow the order of operations. 5.5 plus 8.3 is 13.8. Times 1/2 is the same thing as divided by 2 times 4 gives me 27.6. So this is 27.6 units squared. Right? So again, let's take a look at what we just did here. Okay, so we use the exact same formula for the trapezoid, right? So if you handled finding the area of a trapezoid, you have all the skills you need. The only thing that might get confusing is the fact that you have to do some computation to find the base and to find the height. The height's usually the more confusing one. But yeah, wherever these boundaries are, these are the numbers, these guys, 5 and 9, you're going to plug into this function to figure out what those values are. And those are going to be your heights. And then your base is the difference between these two values. Right? So as soon as you identify those, it's just a matter of sticking it into the formula and going from there. Okay, so I want to try one more of these. So let me go ahead and clear this thing off. Let's see. Okay, so our last example here. Let's see how that'll work. And this one's going to be for you guys to work on. Let me just go ahead and mark this stuff here. 11. Okay, so let's see what you can do. Find the area. Right, the area shaded red, of course. So see what you can do here. Go ahead and pause it here and see if you can get a handle on this. Okay, it'd be easier to get a handle on this if I give you the function. So let's take a look here. So the function actually is f of x is equal to 19.8 minus 1.63x. Okay, so now try to work on it now that you have all the information. Okay, so I'm assuming you've paused it at this point. So let's go ahead and see what we can find. So again, we're going to need the area of a trapezoid, which in this case is going to be 1/2 the sum of the heights times the base. Okay, so we need to find the base first. And actually, if you just look at these, a lot of the time you don't have to do the subtraction. You know that it's 2 units between 7 and 9, right? The base is often quite easy to just look at and see, but 9 minus 7 will give you the same answer. Okay, so we got the base. So now I need height 1, which is going to be f of x1, which is 7. So f of 7. F of 7 is going to be 19.8 minus 1.63 times 7. And we'll go ahead and turn to our handy dandy calculator. Ooh, it's in the way now. Let's turn this guy on, clear that. 19.8 minus 1.63 times 7. Enter. So I get 8.39. Okay, so that's H1. Now we need H2, which is going to be f of x2, which is f of 9. And f of 9 is going to be 19.8 minus 1.63 times 9. So we'll go ahead and work on that now. So we have 19.8 minus 1.63 times 9. That ends up giving us, where did it go? 5.13 is that one? Oops, wrong button. Try that one. 5.13. Okay. 5.13 units. Okay, so now we have all the pieces. We have the base, we have height 1, and we have height 2, so it's just a matter of plugging it in now. So the area is going to be 1/2 times the sum of the bases, 8.39, plus 5.13 times the base, which is 2. And that's actually very fortunate for us because as far as multiplication goes, I can multiply the half times the 2 and they cancel each other out before I even start. So 8.39 plus 5.13, we can do pretty quickly here. And I'll do it on the calculator. Come on now. So 8.39 plus 5.13 is 13.52. And that's our area. 13.52 units squared. Now, it's units squared because I didn't give you feet or centimeters or meters or miles or, any unit of distance. So all areas are given in the square units of the distance. Okay, so yeah, there we go. So that wraps up the material that we're going to have on this next test, right? So you need to be able to find those areas under the curve in addition to anything else we've covered. And in any case, until next time, keep your pencils and your wits sharp.